So in the last video, we talked a little bit about how to solve the problem of word break. We realized that a greedy solution wouldn't necessarily work, and we said maybe we should just try a recursive solution where we kind of just try everything. And here we're going to think about how we can start building out a recursive solution. And like with all recursive solutions, we want to start off with subproblems. So how are we going to break down our current problem of word break? Well, the problem's name is word break, and we're going to break that problem down into subproblems. So how do we create subproblems? One trick that is helpful sometimes when thinking about recursive subprobleming is to just think about what an ideal solution would look like. So remember for this example, we had we had an example where S equals LeetCode, and then we had a dictionary. I'm just going to use WD to represent the word dictionary. We had two words. We had leet, and then we had code. And then the solution looks like leet plus code. More generally, if we have a string S, say it's that long, what we want our solution to look like, is the string S broken down into discrete words that are from our word dictionary. So let's say we had our word dictionary here. Let's say we had our word dictionary here, and it was a set of words W1, W2, and so on. Our solution would look like a set of discrete words from this word dictionary. Maybe this is W2 here, maybe this is W1 here, and so on and so forth. That can be combined to create the solution. Looking at the solution, it becomes maybe more apparent that one type of subprobleming we could do is picking picking the first word and then moving on with the rest of the solution. What I mean by that is this first part of the string can really be one of multiple words, perhaps. So let's say that here we had, let's say for our example here, say we had the string LeetCode, and their dictionary was comprised of the words leet and then code. Let's say we also had the word LE here. This is where that ambiguity came into play that we talked about last time, where we don't know if the first word here should be LE or it should be the LEET from leet. And a recursive solution says, let's just select one of them or try all of them, right? So our solution could actually look like leet plus something else, or a solution might look like the LE plus something else. At this point, we don't know. But we're going to try all of them, and that's going to motivate our recursive solution. And I'm going to draw it out as a diagram and some pseudocode, and then run through a specific example so that we understand it better. But again, I'm going to call this this recursive solution. We're going to say our strategy will be to we're going to try everything as the first word, and move on. That's going to be our recursive strategy. There could be, our solution might have many possibilities for the first word. And while we're building out the solution, we don't necessarily know which of those multiple choices is correct. So we're going to try all of them and then move on.